Question.
Yeah.
For the pre-lab, were we supposed to change the top portion where it was created by you, or
No, you
were we
don't have
supposed
to
to leave
change.
it?
No, you can leave the
No.
header. It's fine.
Okay.
So, start with the pre-lab since we're talking about it. Debugging practice. Okay. So for this, the idea was that you guys got some practice with. Sorry, one sec. You guys were going to get some practice with how to use the debugger tool and just general practice of how to debug code, meaning there's something going wrong with it and you guys are going to figure out what it is. So for the debugger tool in particular, what the debugger tool allows you to do is pretty cool. Let me make sure I'm recording. Okay, cool, yeah. The debugger tool allows you to identify a certain point in the program where control will be given to you to do manually. I'm just going to put this. What you first have to do for that is create a breakpoint. All you do for that is just click on the line number that you want a breakpoint on. The line number has to have some code in there for it to be a breakpoint. And then you just run the program with the debugger. So before I do any of that, I usually like to just run the code once, just normally, and see where the breaks happen. So we're going to run it once regularly. How many layers in the pyramid do you want? Here's what we expect. What do we get? Oh, we get a loop that goes forever. So because of what we know about loops, and because we know that we just got stuck inside a infinite loop over here, where it was just printing on a single line for seemingly forever, we know that we probably have some issue with one of the headers in one of these loops, right? It makes sense. So let's take a look. So the idea is we're going to print a new line for each level of the pyramid, and each level is going to have one more dot than the previous. So the first level has 1 dot, second level has 2 dots, third level has 3, and so on and so forth to whatever size pyramid we want. So let's look at that. First, the outer loop is usually what controls each line, and inner loops will control how many of the items happen. So let's look at the outer loop first. So I is equal to 0. I is less than or equal to levels, and levels is however many levels we want. Okay, that looks okay for now. The bigger problem we know is here, because we only are printing one line, and it's going on forever. So let's take a look at the inner one first. J is initialized to I equals -1. Kind of weird. What's going on here? Keep going while J is greater than 0. Well, if J starts at I -1, that means it starts at -1. So this doesn't work. Then it increments once. And it quits out of this. Then we come here. I is equal to 1. Well, I -1 is 0. 0 is not greater than 0, so this is not going to run. We go next. Then we get here. I is equal to 1. Or sorry, I is equal to 2. 2 minus 1 is 1, which is greater than 0, so we're going to go. Oh, but then we increment it. So that means this is always going to be true, right? At a certain point, at a certain I, J will always be greater than 0, right? Everybody follow me so far there? Did I lose anyone so far? Sounds like no. Good. So let's address that. How far do we really want each line to go? Well, for each line, it should really just be whatever the number of dots for that line number, right? And if I starts at 0, so at level 1, I is equal to 0, and this is what we call index numbering, because the index is always 1 less than where you start. So the first row is index 0, second row, and we'll write this here, first row is index 0, second row is index 1, third row is index 2, right? It's always, the index is always 1 less than the row number. what we would conventionally number it. Because in computer science, we start numbering things from 0. So if we say for int j equals 0, and we want j going so long as j is less than I plus 1. So if we're starting from numbering from 0, and we want to go 1 times, right? And I is equal to 0, or I is equal to 0, so I plus 1 is equal to 1. J is equal to 0, that is correct. So we run it, we print it out, and then at the end of it, we're like, oh, no, J is no longer less than 1 because J will now be 1. And we'll see that here in just a second when I run this thing. So this looks good to me so far. Let's take a look and see if it actually works, right? How many of you guys think this change is enough? What I did here, how many of you think that this is enough? Nope. Justin says no. Who else says yes or no? Okay, we got a few more no's. Can one of you who said no tell me why no? Why is this not enough? You know what? We don't even have to sit here debating. We can just run it and see. So if we run this thing, how many levels do you want in your pyramid? 4. 1, 2, 3, 4, 5. Oh, it printed out an extra level. That's not right. This is only supposed to be 4. Well, why is it printing an extra level out? Who can tell me? Looking at this code, why is it printing an extra level out? Why are we getting a 5th one?
Because of the +1, maybe?
No, because this one, as we saw, controls each row. It controls the number of dots. The levels, the number of rows, is controlled by the outer one.
Oh, it could be because you have 0 and then you have 4. Like you have 0, 1, 2, 3, 4, which is 5 numbers.
What do you mean?
Like you started from 0 and then you went up to 4.
How about here?
Yeah, and that printing out 5 layers.
Jimmy's got it right. It's that because we're saying less than or equals to, it's going to print out an extra time. So we're numbering from 0 to levels -1, essentially, is what this comes out to be because of integers, right? Because integers don't care about the 0.99, the 0.57, whatever. Like there's no decimals involved in integers. So when we say less than, we're basically going up to and including levels -1, which is of length -1 is always the max index. We'll talk more about indexing when we get into arrays, but just know that in computer science, we number things starting from 0. So let's say we have 4 items. Oops, I wrote this wrong. It's supposed to be 3. Let's say we have 4 items. The index of the max index of those 4 items is going to be however many items, 4 minus 1. So in this case, right, the biggest index we have is 3. And the relation to that is, always remember that max index is length -1. This is a constant rule, and it's very, very important to remember this because that is the relationship between length and index in computer science and software. So if we run it now, it should work. And let's give it a try. Yep, it goes. Now we're running into another issue here. It asks us for the name, but it doesn't actually ask. It doesn't give us an opportunity prompt. This should feel very familiar because you guys have debugged this before for your first labs. Who knows what I need to do?
Don't we have to close the scanner for the beginning one? So because we asked for how much layers you want, you have to close it because you're using another next line.
Nope, you don't close it. You
Or not close it,
but
but you use the same next line to end the line.
It's close. Let's go over real quickly in the whiteboard what's happening. So when I type something, when our user gives us some data, Like, let's say, give us your name. My name is Turk. Okay. When they hit enter, this /n, aka the new line carriage symbol appears in the input buffer. This is the system input buffer, system.in. Right? We're watching the system input buffer. That's where we're listening. When we create the scanner, we tell the scanner, hey, listen to the system input buffer. That's what new scanner system.in does. And when a user types, they hit enter, it sends the stuff, but it also leaves a new line character. Now, this is normally system input buffer system.in. So normally this is not a problem because usually because next line, whatever's in the input buffer, next line reads up to and including the new line buffer. So after next line, we'll call it NL. After next line runs, then all that's left in the buffer is just empty, right? There's nothing left in the buffer. So now when the user gives us a number, in this case 4, and they hit enter, next integer, NI, we'll call it, scanner next integer, only reads up to the first integer that it encounters. So if there was a space here, a period, like anything, next integer would ignore that and just give us back the integer that it read up to. And the rest, it moves it out, and that leaves one dangling new line carriage in the buffer. Now, for everything except for new line, this is not a problem because they know to ignore it. Everything except for new line knows to ignore this thing. The problem comes in when we have something that's not new line, or the problem comes in when we start using something that is new line, going from using something not new line to using new line. We're going to have a leftover new line carriage in the buffer. So we need to clear that before we actually ask the user for the input, which is what we do here. Come back to the code, which is what happens here. This clears the input buffer. You only need to do this when going from using not new line to using new line. That's the only time you need to use it. So we fixed that. Let's run it again and see what happens. Okay, we don't get any output. Let's think about why that's happening. Again, if your loops ever behave in a way that you don't expect them to, 90% of the time, the problem is somewhere in here. So let's take a look. We initialize integer I to string.length. In this case, it's going to be 4 because I said Turk. While I is less than 0, and I minus minus. Well, this is never going to be true, right? Because string.length is always going to be greater than 0. So we're never going to actually execute this code. So going back to indexing, we have indexes 1, 2, 3, 0, 1, 2, 3 on our string Turk. And I'll actually put some spaces here to make it a little bit easier to read. So when I enter in this string Turk, I get these indices, 0, 1, 2, 3. What we want to do, because we're reading this thing backwards, right? We start from the last index and work our way backwards. So how do we, if we want to start at the last index, how do we get that? We want to initialize our counter at the last index. How do we have that? Is this going to be the last index? Is the length of the string the last index?
It'd be length -1.
Correct. And then what else? Because this condition is never going to be made true. What do we got to do here? What's the end condition? How far, if we're reading backwards from the third index, when do we stop reading it?
When I is greater or equal to 0.
Correct. And over here, just to be consistent with my output, I'm going to leave a space here so that it prints out a space in between each. You didn't have to do this. I'm not going to take points off if you didn't do this. Since I gave the space for the last one, but not this one. So 4 layers. And my name is Turk. Perfect. We fixed it. That is the assignment.
I got a question.
Yeah, sure.
Does the for loop does our for loop have to be exactly like your for loop? Because I did once differently and then it still worked.
If you got it working, that's
Yeah.
fine. I will
Okay.
leave notes about if I thought there was a better way to do it or not.
Okay.
But if it works and does what it's supposed to, it's fine.
Okay.
Let's go on to the sorting hat one. And I know this one is one where people had some confusions, and we'll go over that. So normally I don't like giving assignments. Like when I write my assignments, for instance, this one, I didn't write this one. I did write this one. My assignments, I usually don't give you guys strict rules like do this step, then do this step, then do this step. I give you general requirements and features that you need to implement for your program, and how you go about implementing that is kind of up to you. Very rarely will I specify you have to do it this way, because if I do that, it's because you have to do that a certain way so you learn the skills. This is one of those instances where I force you guys to do stuff a certain way so you get used to using those skills. And that way being, you had to get the user's input to these strings, and then you had to convert, you have to store the response to each of these as a Boolean. That was a requirement that I had for this assignment. So I'm going to go about doing this assignment the way I would do it. And that doesn't necessarily mean this is the only right answer. If you guys wrote a program that fulfilled all the requirements of the lab and you did it differently, that's totally okay. You don't have to do things the way I do them. Mine is just one of potentially many solutions to it. So let's start out by creating our scanner. And you can name your scanner whatever you want. I just called my scanner object SC. You could also call it input because it's listening to the system input buffer. But the naming is whatever you want it to be, the variable name. For the next ones, I am going to show you a cool little trick. So we know that I know that I want to store each of the answers to one of these questions as a Boolean. Now you could name this thing like question 1, question 2, question 3. That's okay. But I want to be a little more descriptive with my names than that. That way, later on in the code, when I'm reading my stuff, I don't need to go back and reference what Q1, Q2, Q3, A, B, C, D is, right? I could just read, okay, do you consider yourself brave? Boolean is brave. We'll call whatever answer they put for that is brave, right? They are brave or they're not brave. Is class clown will be the next one. Is competitive. Competitive. Is good listener. Is family oriented. Call it that. Is leader will be the last one. 1, 2, 3, 4, 5, 6. Cool. Perfect. And this is one thing that you guys can do when initializing multiple variables of the same type. You can just put them in commas, and I could even do like false was true, yada, yada. I could do something like this as well. These are both valid ways to initialize multiple variables of the same type. Give me 1 second. Sorry, I got to check out what that noise was. Sorry, there's construction crews downstairs, and it sounded like something fell if one of the dogs got out or something. All's good. Okay, where were we? So now I'm going to go about putting in the questions. I'm going to do this in a very quick and dirty manner. Just going to copy paste all these in, right? Because that's what we have to do. We ask them. And if anyone of you is wondering how I'm doing this, you write S out, and then you press tab, and it very quickly makes system.println for you. Okay, and I'm going to create a new variable, string input. That will store whatever input they have. So input equals scanner.nextLine. We grab their input string, and then they are brave if input equals ignore case, yes, or we also accept letter Y. Another way I could do this would be to say that to uppercase, or you could say lowercase, doesn't matter, and then yes, in all caps, or and then over here, to uppercase equals Y. These both accomplish the exact same thing.
I have a quick question.
Yeah.
So I kind of use like two uppercase and equal sign, but I also use another one which is I think was contains also. So
Contains is something different.
Oh.
Contains could be true if they said, like, let's say they said eyes. It would still say true because eyes contains the word yes, but that might not be what they meant. We're specifically looking for the word yes or the letter Y. That's why we use these two specific things. Because if it's a typo or something else happens, we just want it to default to false, right? Like let's say they typed like EYS as a typo, it's going to default to no. It's going to default to false. So we could just copy this for each of the other ones. Is class clown, is competitive, is good did I say listener? Is good learner, is family oriented, and then we'll call this last one is leader, right? Duplicate code. Well, I mean, these are all technically duplicates. There is other ways that you could do this without there's definitely other ways that you could do this. One, if you really wanted to get fancy with it, you could write sc.nextLine. So everywhere there's an input, just put, oops. Everywhere that it says input, just put this. And this would technically, and you can remove the string, this would technically be faster. By the way, those of you who are wondering why this another string thing pops up, that's not actually part of the code. That's just the interface label for me to know, because if you look at the function declaration, the method declaration for this specific method, the parameter another string, that's the name of the string parameter. So IntelliJ has this cool feature that when you're writing program and you invoke a method, if the data you provide is not actually, if it thinks like, oh, that's not really indicative of what it is, it'll remind you, hey, this is what you're entering in for the parameter. It's just a nifty little helper. So yeah, here we go. We condensed 2 to 3 lines of code into 1 line. Look at us go. We're so cool. Hooray. And then at the end here, we have to decide what house everyone goes into. So if they are brave and is family oriented, or they tend to be a leader. So if is brave or is family oriented and is leader, you are a Gryffindor. And I'll just copy that. Else if, let's see what happens if they're Slytherin. If they are not the class clown and they tend to be competitive, is class clown and is competitive, Slytherin. Else if, how did they get to be Ravenclaw? If they are a good learner or competitive, if they are is good learner or is competitive, and and is brave, but is not the leader, then they are Ravenclaw. And else if some of you might have put else and said Hufflepuff. In this specific case, that's not correct. Just because we'll make another else statement just in case they're not anything. And if someone is class clown and is not brave, is class clown and is brave, is not brave, then they are Hufflepuff. And it's usually good to have a last cache this amount. Prin, sorting hat doesn't know where you belong. We'll just say that. Usually we won't come into this. There may be some very specific edge cases that I can't think of off the top of my head that this might happen, but it's good to have. Just so that your user has some feedback. Isn't it brave and family oriented, or is a leader? For which one are you talking about? For Gryffindor? This one in particular, I actually gave in, or it tends to be the leader. Oh, wait, you're right. I'm sorry. You are right. It is or. Yes. It is brave and family oriented, or is leader. There we go. And mission is always true when reached. And if we run this, just to make sure everything works, let's try to get Slytherin just because it's easy. That is, we're Slytherin if we're not the class clown and are competitive. We'll just say no. Hello. Are the class clown? No. Oh, that's annoying. Oh, okay, I know why. Forget what I said about here. This should be inputs. I need a string inputs, and then input equals SC, that next line. We need this every time, otherwise it's gonna ask us to put in, yeah, okay. Yeah, you need to do it this way, sorry. You don't wanna condense it to one line like I did. This is a mistake, don't do this. Do it this way. I'm not gonna do it for each and every single one, but you guys know what I mean, right? Do it like that, not like this, because that's not gonna work. Anyways, on we go. That is a sorting hat class. That is a sorting hat program. Cool. Let's talk a bit about GitHub. So GitHub is an online repository, is basically a collection where you can have repositories, collections of code for different projects. Like here's a project that I'm working on privately for a Shadowrun system thing. Here's a project for where I created a web server. All the code is here. Here's my source folder with all my stuff. I have all various, all sorts of different repositories with different code in here. This one I'm going to delete real quick because we're just going to make a new one. Trying to remember how to delete actions. I can't remember how to delete repos. Whatever. Just gonna go to my desktop. CSC 211. Sort by name. Where is it? Where's the GitHub? Oh yeah, I put it in my desktop, I think. Yeah, GitHub demo. Let's get rid of that. So what I did to do this, first of all, if you don't have a GitHub account, you have to create a new one. That's pretty straightforward. You can click here, new repository, and you'll fill in the repository name. The repository name is whatever you name it. It appears here like this. It's usually good practice to use like camel case, or sorry, Pascal case, like this, right? Pascal case is where every word starts capital. So you can give it some kind of description. I recommend adding the README file. That always helps with forming a repo. But I already have a repository here. Right now, this code exists in the cloud, or rather in the GitHub repository. It's your remote code is what we call it. To get it to your local, meaning your local machine, your actual computer, you have to use your terminal a little bit. Now, you can use the GitHub desktop app, but I recommend you guys get used to using the command line interface or the CLI, and here is why. In the professional world, and very soon after, within like a year or two of your CS classes, your professors are going to ask you to start using GitHub on the terminal, and a lot of them don't use the desktop app. Most people don't use the desktop app. So that if you have problems with the desktop app, they won't know how to help you. And it's better to use the command line terminal. It gives you a lot more control over everything that happens. Yeah, the desktop app looks nicer, but there's so much more stuff that you can do from the terminal, and just takes a little bit more practice. And I personally use the GitHub command line interface. I use a terminal to use GitHub, so I recommend you guys do that as well, because I can best help you with that. Anyways, we have this remote repository, and we want to bring it to the local. That way, we have a link established between GitHub and our local machine. So whenever I'm working on this project locally, when I save and commit and push my changes to GitHub from my local, it'll reflect in GitHub as well. Think of GitHub almost like a code Dropbox, right? It's a Dropbox for code. Let's go to my terminal, clear this, and we're in desktop, right? So here's my desktop in the graphical OS, and then here is my desktop looking at it from my terminal. You guys can look up commands for how to navigate your terminal. The basic ones you need to know is ls.la will show you everything, will list all the stuff in your, in your whatever folder. CD stands for change directory, and then you can put it to wherever. So like, let's say I want to enter this directory, the CSC 211. I can do ls-la, and here's all the stuff that was in my directory. If you want to go up a level, you say cd ... You go up a level. You can make new directories by saying make dir. And then to bring my GitHub repository here to my desktop, I'm going to say git clone, and then paste the URL that I copied from here. And it's cloning it to GitHub demo. So now if I go to my desktop, here it is, my GitHub demo with the README file. Let's say I want to make changes to this README file. Why did it open an Xcode? I don't want you to open an Xcode. Do something easy like, okay, whatever, we'll do GitHub. We'll use Xcode. I am making changes to this README. This is changes for demo for section 2. Okay, and I save that. Right now, these changes only exist in my local. If I refresh this, it doesn't automatically change the stuff in the remote. The way that I get stuff from my local to my remote is I have to push it. I have to push these changes. So what I have to do is I have to stage what's called a commit. A commit is a single file or multiple files that go along with some change that I want to implement. Let's say I'm writing code. Let's say I'm building a project, and part of the project involved me adding an interface for a new menu, okay? I would create a whole commit for just that menu, right? Maybe let's say for creating the menu, there's multiple things involved. There's putting the actual interfaces, like putting in the graphics for the actual interfaces. That's one commit. Then another commit would be creating the functionality for those menu items. That'd be another commit, etc. Commits are usually best kept small and to a single task. You should be able to describe in a single line what a commit does, because that's the whole point. So I made changes to the README file. Let's go to GitHub demo. You need to enter into the directory on your terminal. You need to enter in the directory of the whatever folder you're working on for your project is, the folder that you pulled from Git or pushed to Git. And then you're going to say git add, and you can put dot, or you can put specific file names. I just put git add dot when I'm just working quick and dirty. And for most of you guys and stuff, because it's going to be like single file projects, you can always just put git add dot. We'll get into more specific stuff later. And as we get into more nitty gritty stuff with GitHub, I'll show you how to use like, I think IntelliJ has built-in GitHub support. I don't remember off the top of my head. Anyways, you say git add. It is added. All the files you've changed have been now added to the GitHub, to the commit that you're going to push. Now you say git commit m -m. This is saying I'm going to create a message for my commits. And you say change for section 2 demo. And now the commit has been created with this identifier. And then we say git push. This is, up until now, all my changes are still local. They're staged locally. They're not pushed to the remote yet. Once when I say git push, it's going to run some stuff. Then it's going to say done. And if I refresh my repository, now I see the changes that I put into the README file, right? And we can even see the name of the commit here. And if I click on this, it'll actually show me what file I changed and what things I changed about that file. This red means we removed this line, and this is new stuff that we added. So I'm sure you guys can really quickly start to see why this is such a useful tool when you're working with code. You're going to run into many, many times where you'll be working on a code and you'll make changes and you're like, oh crap, I changed a bunch of stuff, but it made it so that my code broke. I want to go back to the earlier version, the working version, my last save. There's not really an easy way to do that aside from making copies of files in your local. But with GitHub, as you work on stuff and as it works, you can make commits. You can leave messages for yourself. You can remind yourself of the different progress, and you can revert commits. We'll get into that later down the road. But it's such a handy tool because let's say you make some changes locally and your code breaks. Well, you can go back into your remote repository, revert a bunch of commits, and then pull from your remote to your local, overwrite whatever you have locally so that it's in sync with your remote. Let's say I suggest some changes and I make changes to your code on the remote and it helps you fix an issue that you had. Then you can, again, pull from the remote, overwrite the local. There's a lot of really cool stuff you can do. And GitHub does a really great job of tracking every change that happens. So you can always step back and revert and whatnot. And you always have a nice little audit log. So that is GitHub. I won't be posting any tutorials on it. And the reason why is because there's so many tutorials online. If you go on YouTube and look up how to use GitHub. And I recommend a guy called Traversy Media. There he is. This guy is really, really great. freecodecamp.org is really great. Both these guys have really good videos that, Codecamp is an hour long in-depth tutorial about how to use it. There's also basics like this one right here, 8-minute video, really quickly goes over GitHub. There's so many better materials out there than what I could create. I encourage you guys to go out and explore it. These guys are going to make stuff and explain stuff better than I ever could to you. I'm sure of it. And, maybe like some of you guys understand these guys better than me or vice versa. Or maybe there's some other channel out there who explains something in such a way that you get it. Maybe you don't understand it here in class. Maybe you understand when you watch the video. That's why I say, don't just rely on me for being the only source. Go out, find your own sources, explore the internet, do some Googling, look for tutorials, because there's a lot better tutorials out there than what I could put together. Any questions so far on Git? I know I covered a lot in a very short amount of time. Any confusions, any questions at all? Because you're not going to need to use Git for this week's lab. I won't require it, but in the future, I am going to start asking you guys to start using Git. And if you're If you're having troubles in the beginning with Git and your submissions are late because of GitHub problems, that's totally okay. I'm not going to mark you down for it. We'll put a note. We'll work something out. I really want you guys getting comfortable with this tool. Even though it's not required for your first year, I think it's really, really good to start using it early because you're going to use this in your professional life. You're going to use this throughout your computer science path. And it's just going to make it so much easier for me to communicate with you how to fix your code. What I think about your code is needs work, or what I would change, rather than me and I learn through the comments in the rubric trying to say on this line at this part, do this instead of that. It's so much easier for me to suggest changes in GitHub and you see it in the code.
I got a quick question.
Yeah.
So whenever we're gonna be graded, you're gonna be checking our GitHub also, and then that's like where you're gonna be scoring, or is this still gonna be like transferred over to iLearn?
So what's gonna happen is from here on out, I'm gonna look into how to use GitHub Classroom. So I'll have everybody's repositories there. Most likely what I'll have you do for the iLearn submission is just submit the link to your specific repository. So I could go straight to your repository, check out your code, grade it from there. But the comments, your grade will still be in iLearn, probably, but I will have comments in GitHub. One of the things I want to look at with the GitHub thing too is I can create unit tests for your code. So like, let's say you have a lab assignment and you're like, oh shoot, like does my code work? Is this what he wants? For certain assignments, I could create tests that you could put your code through and see if it works. And the test will give you a good indicator of how you're going to do. I don't have any of them ready yet, but probably for future labs, that's something I'm going to look to try to have for you guys. That way you have some indicator of, is my code going to get a good grade or not? Okay. Any more questions about GitHub? And if you guys, while you're working on it, and if you guys have questions while you're working on GitHub, please use the GitHub discussion channel, not the homework channel. Keep those separate if you could. The reason I ask for that is so I don't have to, it'll be easier to keep those things separate. One channel, when you guys go in later looking for answers to a specific thing, whether it be homework or GitHub, you know where to go look for those answers. Let's talk about the lab this week, Chapter 5 lab. I did leave a note here, and it'll make sense as we go through the lab, but this is just a reminder for you. Keep it in mind. This week's lab, using loops, you are going to create the Fibonacci sequence. You're going to create a program that's going to ask a user for how many digits of the Fibonacci sequence they want to see, and then you're going to calculate up to that number. So like, let's say they want to see up to the 5th number, you'll calculate the Fibonacci sequence up to the 5th. There are a few constraints. Number one, over here, it asks the user for a number of terms. They give you a number of terms, and then you give them an error message saying this needs to be less than 20, and then it exits. For your code, I want it to not exit. And we'll talk in a little bit about how you can go about doing that. But you're going to keep asking the user for input until they give you proper input. Proper input is any number between 3 and 20. At minimum, you'll only print to the 3rd term of the Fibonacci series because the first 2 terms are preset. At maximum, you'll print 20 terms just because that's an arbitrary limit that I put in. Now, for oh shoot, we haven't done the loop demos. We'll go into that after this talk about the lab because it'll tie in. But that's basically it. What the Fibonacci series is each number is the sum of the 2 numbers that come before it. So the first 2 numbers in the series are always 0 and 1. The 3rd number, which is the minimum you can print to, is the sum of the 1st number and the 2nd number. Then the next number is the sum of the 2 numbers before it, and so on and so forth. You guys can look at the series and see. I'm sure if you Google Fibonacci series, it'll like print out to however many numbers. That's how you can check if your output is correct or not. Should be a fairly straightforward lab. Don't worry about the grading part. Another instructor wrote this. I'm not going to be following this. I'll update the rubric on iLearn so it'll be more reflective of what I'm looking for from your code. But let's talk loops because I somehow completely glazed over that. Today's discussion is on loops. There are 3 kinds of different loops that we can have. Who can name them all for me? Or just shout them out in the chat, I guess. Or
I guess one of them will be for loop.
Yep, for loop.
Another do while. Yeah.
Yep, do while. Yeah. For loop is fairly straightforward. You say for, and then you have init the counter. You initialize the counter here. And then you set condition for however long the loop's going to run. And then you, this is what's called the step the counter. The reason why I don't call it increment or decrement is because you can increment by 2, you can decrement by 1, you can increment by multiple numbers. There's different ways to do it. So more generally, we refer to that as we'll just call it update the counter. Update the counter. So basically what this says is we have some counter initialized at this. This loop is going to run until we meet this condition. And after each time the loop runs, we're going to update the counter as defined by this third section here. And I'll give an example in just a second. While loops are pretty simple. You say while condition. So long as the condition is true, the loop will execute. It'll check the condition, execute the loop. Check the condition, execute the loop. So long as the condition is true, it's going to keep doing that. Do while is exactly the same as while, except that it does the body first, and then it checks the condition. And we have a semicolon here. It'll run this body first. After it's done running, check the condition, and if the condition is true, it'll run the body again. That is the key difference between these two loops. Do while runs, then checks, while checks, then runs. Right? Let's do an example for each. We'll just say for int I equals 0, I is less than, I don't know, we'll just give some random number, 23, okay? While I is less than 23, and we'll say I plus plus. And each time it runs, we'll just print out I, right? Gonna comment these out real quick so that we don't get syntax errors. Now, edit configurations, application, call this loops demo. Demos.loops, okie doke. So if we run this right here, it's gonna print out 0 through 22, right? So there's other things I can do in here. I could say I plus equals 2. Let's say we're jumping by 2 every time. There you go. And you could also do it like I plus equals 1. This thing is exactly the same as I plus plus. These two things are exactly the same. I plus plus is just a very specific shorthand that exists, just because it looks neater than plus equals 1. We could say plus equals 5. You jump like that. Obviously you guys get it. Any number can go here, and we could even do like minus equals 5, but then the condition gets violated. For the while loop, let's say, just name it Boolean is hungry equals true. We'll say while is hungry is hungry is true. Print hippo eats, and then we'll say is hungry is equal to import Java until random. Java generate random integer. I could just use math.random, I guess. Java math random. Just want to make sure it generates an integer. Turns a pseudo-random double type number. Oh, okay. Java random next int. Next int. That's fine. Equals random dot next int. new random next in. Over here, I'm just generating. What the hell? Why can't? Oh, it's not static. That's why. Okay. I'll just say random RNG is equal to new random RNG dot next int. So basically what I'm doing here is saying I'm generating a random number and assigning the Boolean value to if rand number is even. We'll talk about the, who doesn't know what the modulo operator is? Just say no or me or whatever in chat if you don't know what the modulo operator does. And it's okay if you don't. We'll go over it.
I have a quick question.
Yeah.
Boolean works like if it's 0 and 1, right? So if it's true if it's 0 and if it's false if it's 1, correct?
Nope, because it is a random.
'Cause I think
But by 0 or 1, it's a, so we can say 0. It's going to give you an error because it's an integer. So you'd have to convert the integer to a Boolean value. And we can even look that up. Convert integer to Boolean Java. You are correct that 0 or 1 is a yes or no, because this is kind of getting ahead to machine structures, but a 0 or 1 just means a gate is open or closed, which represents a true or false value. But we can do that here to something like Boolean bool. Yeah, we'd have to do it something like what I was doing here. If this next integer is even, you need some kind of Boolean way to convert this to a Boolean. So this whole thing is a logical statement, which is Boolean. So we're checking if this is random. For those who don't know, what the modulo operator does is it divides this number by this number and gives us the remainder. Division gives us the whole number, right? Integer division is just like division that you learned in elementary school. 6 divided by 3. 3 goes into 6 2 times with no remainder. 6 divided by 4. 4 goes into 6 1 time with 2 remainder, right? That's basically, modulo operator gives us the remainder. Division gives us the whole integer. Anyways, basically what I'm doing here is while is hungry, we're going to print out the statement hippo eats. And then when whenever the random number generator gives us an even number, we're going to set, or gives us an odd number. As long as we give an even number, we're going to keep going. If we get an odd number, it's going to make this a false. And then we're going to bust out. And we'll put a statement here. Hippo is full, right? So if we
just
run
to
this,
double check, the logical operator is what's causing it to be even or true. It's true and false, correct? The equal
Yes.
sign. Okay.
So the way we check for even is if a number divided by 2 has no remainder, that means it's even, right? This is just basic math stuff, right? That's how we check if a number is even. We divide it by 2, and if there's no remainder. So that's basically what we're doing here. This whole thing is a Boolean statement that checks if divided by 2. This specific thing is what's specifically checking for it to be even. Or like it all kind of works in conjunction. Hope that's kind of making sense. I think I'm just making it more confusing by breaking it down.
No, it makes sense. It makes sense.
So yeah, and if we run this right now, it ended up running 1 time. We can run it multiple times. See, this time we ran a few more times. Hippo ate 3 times, and then it was full. And then if we say do while, and actually for the do while, we'll make it so that hippo, we'll say, just to illustrate, do while is hungry, right? Another hippo eats, or we'll just say same hippo eats, just to kind of illustrate, different things. So even though hungry is going to be false when we get here, we're still going to run the code inside of the do while loop once. So this is kind of like serving as a warning. Be very cognizant of the difference between the while and the do while loops. The do while will execute and then check. The while loop will check and then execute. There's no hard set rule of when to use one or the other. You really just have to understand their behaviors. And when you're writing code, think very logically about the steps that you're trying to do. That's why, we did the exercise at the beginning of the semester where I had you guys break down the peanut butter jelly thing into very specific, simple binary steps. That's what you have to do in software. You have to take a task that you're going to do and break it down into very simple, easy steps, because that's how you communicate it to the computer. Anyways, that's the loop demo. Let's think a little bit about the question. One thing to talk about with loops. How many of you are familiar with the terms discrete and continuous? How many of you have heard these terms before, maybe in a math class? Discrete and continuous. Yeah. So continuous means it goes on forever. Discrete means there is a set number. There's a specific amount that we know beforehand. So usually, for the most part, when you're in a situation where you're dealing with a discrete scenario, you know how many steps something's going to take, you'll use the for loop. When you're dealing with a situation of continuous, like you don't know, it's going to go until some condition, but you don't know how many steps that's going to be specifically, that's when you'd use the while loop. So let's consider the scenario. We want to keep asking the user for input until they give us proper input. Is this discrete or continuous? Do we know how many times we're going to have to ask the user for input before they give us correct input?
Are you asking for the lab or the program right here?
I'm asking you in general.
Oh.
In a scenario where, okay, we'll give it in a demo. Give me an even number, right? And we'll say, okay, we got our scanner. SC is equal to next, int input is equal to sc.next int. Right, and in fact, yeah. So we have this input integer, right? Do we know how many times we'll have to ask the user for an input before they give us proper input? Let's say a user keeps giving us odd numbers, right? How many times should we ask the user for a new input? Do we know?
Nope.
So what kind of situation does that make it?
This would be continuous then.
Yes. So which kind of loop do we want to use?
We would use a while loop.
Yes. We'd say while input 2 does not equal 0, input module 2 does not equal 0, print that is an odd number, please give an even one. And we would say, I just have this over here. Once again, ask the user for another input. Right? There's other ways that you could do this as well. This isn't the only way, but this is one way to do it. But the general idea is still the same. In a while loop, you're going to ask the user to give you proper input. Remember, proper input for the Fibonacci sequence lab is a number that's between 3 and 20. So you have a minimum, you have a maximum. That's something you have to consider when structuring your check for the conditional, or if you have if statements inside your while loop, whatever you decide to do, however you decide to lay it out. But that's kind of like the big hint for how to do that. And I have a reminder of that here. The demo shows the program ending after one input request from the user. For your submission, you must error check the user's input until they give a valid one. And then I'll even add a, oops, did not mean to click the Zoom stuff. A valid input for this lab is between 3 and 20 inclusive. Okay. Any questions on the lab, on anything we talked about this week? All right, today, I guess.
I got a quick question.
Yeah.
Because we're looking for a number between 3 and 20,
Mhm.
it will keep continuously going, or do you want us to like have a number that it stops at? Like if we have like 10 numbers, and then if we like
The
have a
number you're
special.
asking for is how many steps in the Fibonacci sequence you
Mhm.
want to reveal, right?
Mhm.
So that's what that number between 3 and 20 is.
Oh, okay.
So if they give you 10, they expect to see 10 numbers in the Fibonacci 10, the first 10 numbers of the Fibonacci sequence printed out.
So then our max would be 20.
Yes.
Okay.
Any other questions?
Oh, I asked this in a Discord, but when I tried turning in like the labs earlier today, it wouldn't accept the file, and they were both Java files.
Let's take a look. Usually when you go to the submission, it'll tell you what file type it's expecting.
Yeah.
Let me see.
I tried turning it before 12, and it wouldn't like it. I
Mhm.
couldn't turn because it was a Java file. Like it wasn't a Java.
Uh,
It said it was a Java file, but that it said that it would only accept like a text file. That was it.
Oh yeah, it's kind of weird how it categorizes. Text is the category, but the actual extension is .java.
Gotcha.
I couldn't tell you for certain without seeing what exactly you were submitting. It is possible you were submitting what you thought was a Java file, but was in fact a class file or is something else. Just try getting the submission through, and I guess leave me a note that you were trying and you were having errors with it. You should be able to like leave me a comment on your.
Yeah.
So yeah, just leave me a comment. Just say that we talked, and that's okay.
Thank you.
Any more questions? Okay, if there's no other questions, I'll end class, and best of luck to you guys. Reach out to the Discord if you have questions. And like I said, you don't have to put up your homework for GitHub this week. I will start asking for it next week, but I strongly, strongly advise you guys practice using GitHub for this homework assignment. Look up on GitHub how to create a repository from local to remote and the other way around. Today, the demo, I showed you how to create a remote repository and then pull it to the local. You should also be familiar with doing it the other way around. There's plenty of tutorials out there for both of those. You guys have to look into it. Windows users, I recommend you guys get one of two programs. Commander is one. It's a Linux style emulator for your console. Normally, Windows consoles don't use Linux; they use very specific Windows language, Windows OS. So you'll need Commander for that. This is a nice general purpose thing, or you can use Git Bash for Windows. This is another terminal that I like. I've been preferring Git Bash a bit more lately. I just personally like it better, just because I end up using GitHub the most on my Windows, so that terminal works better.
I have a good question.
Yeah.
I'm assuming because majority of the systems that we're going to do in the futures are like Linux based, so we should be using like Linux terminals, or would CMD still work for Windows?
You can make it work. I've worked in professional settings where people were comfortable with both. But for the most part, technologies you are working on, most people in the tech field prefer to use Unix-based systems, whether it be Linux or like raw Unix, Ubuntu, stuff like that.
Okay.
It's better, in my opinion. It's more worthwhile, in my opinion, to learn the command lines for those than for Windows. Because most Windows users that I know use emulators. All right. Any other questions?
Yeah. Lastly, I'm assuming we're still submitting a Java file for the lab for this lab.
Yes.
And then if we wanted to submit, and if we wanted to add like a GitHub, we would just add it in the comments, or would there be another place?
You don't have to submit me your GitHub this time around. Just do it for kind of like your own personal practice to have it. That's really what it is for this time around. Just practice it. Next week, I will start asking for GitHub links. You'll basically, when you submit your homework, you'll just send me the GitHub link through iLearn. That's how you'll do your submissions.
Okay.
And probably, so I haven't decided yet how I'm going to judge what's late. Most likely I'm going to go by your GitHub commits. So if you make commits to your GitHub after the due date, after the time that it's due, I'll probably take points off. So just be aware of that. And I haven't decided yet, but we'll see what happens with the due date. I was considering changing the due time for all labs for across all sections to be Thursday at 11:59 p.m. That way, everyone's late after midnight on Friday, but I haven't decided on that yet. I'll have to think about that some more. But for now, that's what we got. We'll figure that out as we go, and I'll do my best to communicate. By the way, if any of you in the chat is not on Discord, please let me know. I do see a few people in the Discord. These 8 of you still have not selected a role. All you got to do is click on if you're section 7 or section 2, and then you'll be able to see all these other channels. If you haven't done it yet, I recommend that you do, because there's a lot of discussion happening in the homework help section that I'm sure will help all of you. Anyways, if there's no other questions, gonna shut it down, and I'll be uploading the replays, the recordings of these later today.
I also want to note that the GameStone milestone is actually due next week, correct?
Oh yes, the game project milestone due next week. Please get that done, guys. I'll put out an announcement reminding you guys of that. Thanks for reminding me. Okay. Have a good weekend, everybody.